Hello students, in this video we're going to be reviewing filling in a frequency distribution table like the one you see on the screen and creating a histogram, a relative frequency histogram, and a cumulative frequency histogram. So I want you to take a minute or two and begin entering this data into your calculator. This data, for the record, shows the number of hours of sick leave that some employees of a company have taken during the first quarter of the year, rounded to the nearest hour. Take a minute, enter the data into a list on your calculator, and then I'll put up on the screen here what the one variable stat test should have looked like to see if you have the data entered correctly into your calculator. The first value that you should always check is your n value to make sure that you have the correct number of numbers entered, and in this case we have 30 numbers. The average turns out to be a little over 30.3. Now, what we want to do is we want to begin filling in a frequency distribution for the data. A frequency distribution is just a table that you're going to be setting up intervals and essentially counting the number of numbers in each interval. And what we're going to do is this. This particular problem has you setting up 5 different intervals. You're going to be told when you do these questions the number of intervals that you need to use. So here we're going to be setting up 5 different intervals, and the way we start off is by calculating the range of the data. Remember, the range of the data is always the maximum value minus the minimum value. So here the 5-number summary tells you the maximum is 59, the minimum is 10, so here we have a range of 49. Range of 49. Now what we're going to do is we first want to calculate what they call the interval width. Now, in higher levels of statistics, it's called the class width because the intervals are also known as the classes. And what we're going to do to calculate the interval width is we're going to take the range of the data, which we determined was 49, and we're going to divide that by the number of intervals. And the number of intervals is always going to be given to you in these problems. So here we're going to take 49, divide that by 5, and here our interval or class width turns out to be 9.8. Now, here's the most important thing in terms of the setup of these problems. You always have to round up when calculating your interval width. So here, when we do the range divided by the number of intervals, we found that value of 9.8. We're going to round up according to the data that's given to us. In this case, all of the data was given to us in terms of integers, whole numbers. So what we're going to do is we're going to round up to the nearest whole number, which in that case gives you 10. So here our interval width, we're going to make the intervals to have a quote-unquote size of 10. So here is our frequency distribution. And what you always do is you always start off the first interval with the smallest data value, the smallest number in the set. So in this particular case, when we did our 5-number summary before, we found our smallest value to be 10. So we're going to start off our first interval with the number 10. Now, what you're going to do is you're going to keep adding this class or interval width to get the starting point of the next interval. So here we're going to start off with the smallest data value, which was 10, and we're going to add this 10 to get 20. So our second interval is going to start at 20. The next interval, 20 plus 10 is 30, 40, and 50. So you're going to add the class width to the minimum value to set up the starting points of all the different intervals. Now we're going to figure out the ending point of the interval. And what we do is basically we end at the data value before the next one starts. So in this case, our second interval starts at 20, which means the first interval is going to end at 19. Now it kind of just depends on the data that's given to you. here, we're having that first interval end at 19 because we were given whole numbers. If we were given, let's say, dollar amounts for our data set, well, the first interval wouldn't end at 19, it would end at 1999. If we were given data values that were rounded to the nearest tenth, suppose all these numbers up here were rounded to the nearest tenth, then we would have to end the first interval at 19.9. So you always round according to the data that's given to you. So our first interval is going to end at 19, and now we can just simply add this class width to get 19 plus 10 or 29, or we can work backwards. The third interval starts at 30, which means the second interval has to end at one before that, or 29. So this is key to these questions. You want to set up your intervals correctly. Now what we want to do is we want to begin filling in the frequencies. We want to begin determining how many numbers there are in each interval. So what we're going to do is we're going to go to our stat plot feature of the calculator. We're going to press second and then y equals. Now what we're going to do is we're going to create a histogram for the data. The histogram is just basically the graph version of this chart, the graph version of this frequency distribution. So we're going to go and create a histogram for the data. So for me, I entered my data into list 1 of my calculator. That's why you see list 1 there for XList. And just make sure the frequency here is going to be 1. We're not using the frequency list feature of the calculator because we entered all of our data into one particular list. Now the histogram is the only type of graph in which you don't press zoom and option 9, zoom stat. The scatter plot, you would do zoom stat. The modified box plot, the box and whisker plot, all of those graphs, you simply choose the graph that you need, press the zoom button, and then press option 9. For the histogram, what you're going to do is you're going to have to enter the viewing window that you need to match these intervals. So you're going to press the window button and begin entering the data values. The x-min is always the starting point of the first interval, which is always the smallest data value. So your x-min is going to be 10 because the smallest data value in our set is going to be 10. The x-max is going to be 59 because that's always the ending point of the last interval. The x-scale is going to be 10, but not because the first data value is 10. The x-scale is simply the interval width that you calculated to begin these problems. So the x values, the x-min, the x-max, the x-scale, all deal with the intervals themselves. You're going to set your y-min to be 0, your y-max to be half the number of numbers. In this case, we had 30 data values given to us here. So I'm going to make my y-max to be 15. And then for your y-scale, you just choose a factor of the y-max, a number that goes into the y-max evenly. So in this case, the data values, total number of data values was 30. We're going to cut that in half to get the y-max of 15. And then since 5 goes into 15 evenly, we're going to set our y-scale to be 5. So you're going to set up your viewing window this way, and then in order to get the histogram, you're then going to press the graph button. Make sure when you do these frequency distributions, these histograms, you never press zoom and then option 9, zoom stat, because zoom stat is programmed to come up with the viewing window which the calculator has been programmed to set up. For these questions, I'm showing you how you need to set up your intervals, so we need to manually set up the viewing window and then press the graph button to see the histogram. When you press the graph button, your calculator should look like this. This is a histogram. It basically looks like a bar graph, except the bars have all been compressed together. And when you press graph and then press the trace button, your calculator will tell you the first interval, which in this case is from 10 to less than 20, so 10 to 19, and it will tell you the n value, which is the frequency, which is the number of numbers in that interval. So in this case, since the n value is 6, we're going to put in the frequency box 6. And then what you simply do is just keep pressing to the right on your calculator. The second interval tells you that there's 11 numbers, the third interval 5, the fourth 6, and the fifth 2. And a real good way to check to see if you're setting these problems up correctly is to add up your frequencies and make sure that they add up to the total number of numbers that were given to you, in this case 30. So we have the frequency based on this histogram. On exams, you're going to be asked to supply not only the viewing window that you used, but also you're going to be asked to create and draw your frequency histogram. This is not an art class, it's a math class, so I'm not really going to be looking too particular at your artwork, but we want to make sure that here the y max is 15, so that's kind of the high point of this left-hand axis. Here we have a total of 5 different intervals, and we want to draw the histogram to the best of your ability. So this is the frequency histogram that's created from the frequency distribution table. The next column of our chart discusses the relative frequency. And the relative frequency is just simply the percent of the data values that are in each of these intervals. So relative frequency just basically means the percentages. So for example, in this first interval from 10 to 19, there are 6 numbers in that interval. Well, since we had a total of 30 data values, I did 6 divided by 30, and I got 0.2. So that means that 20% of the data values, and normally in statistics, you write that as a decimal. So 0.2 or 0.20 tells the reader of this table that 20% of the data values are in this first interval. Here, in between 20 and 29, there were 11 data values. So if I do on my calculator 11 divided by 30, there are 0.366, or basically to the nearest percentage. That's usually how it's written. There's 37% of data values in that second interval. Third interval, from 30 to 39, has 5. 5 divided by 30, 0.166, so basically 17% of the data values. The fourth interval, 6 data values, so 6 over 30, again 20%. And then the fifth interval, there was only 2 numbers, so that's 0.06 or 7% of the data values. You can add these percentages up and see if you get to 100% or just basically 1. The problem is, since you are rounding, sometimes you're a little off when you add up the relative frequencies. Here I rounded to the nearest percentage, and sometimes when you round up or round out, it kind of affects the sum a little bit. But basically, just understand that the relative frequency is just the percentage of data that occurs in each interval. To create a relative frequency histogram, basically what we're going to do is now convert this column of the table into a graph. And what we're going to do is this. If we look at this column of percentages, the biggest percent that I see is 37%. The most amount of numbers are in that second interval. So since the highest relative frequency is 37%, I'm going to make my y-axis go up to about 40%, just to make sure that the 37% fits on the graph. Then what I'll do is I'll set up a convenient scale that's going to make the graph easier for me to graph. So I'm going to use a quote-unquote y scale of about 10%. So for my first interval, I know there's 20 numbers in that interval, so I'm going to create the bar graph that goes up to 20%. The second interval, there were 37 numbers, so I'm going to make the second interval go up to 37. The fourth, there's about 17%. The next interval, 20%. The last interval, 7%. And what's normally done in statistics is you label the starting point of each interval. So right here, the first interval began with 10. The second interval began with 20, 30, 40, and 50. And even though my y max for the graph was 59, I'm going to stick with this interval of 10 to kind of make the graph easier to read. So this relative frequency histogram just gives the percentage of the data that's contained in that interval. The final column in this table represents the cumulative frequency. Cumulative just basically means a running total of the data. How many data values are contained up to and including that interval? It's a running tally, if you will. So for example, the first interval's frequency is 6. So I'm going to just simply copy over the cumulative frequency is 6. That means up to and including that first interval, there's a total of 6 data values. Well, for the second interval, the 20 to 29, its cumulative total is going to be 17 because the first interval contains 6 data values, the second 11, so a running total up to that interval is 17. The third interval's cumulative frequency turns out to be 22. Why? Because there were 17 data values through the first 2 intervals. There's 5 more in the third, so the running total, 6 plus 11 plus 5, is 22. Here, the fourth interval, the cumulative is going to be 28, because 22 plus the 6 gives you the 28. And then my last cumulative box is going to be 30. A good way to check to see if you did this right is if the last value in the cumulative frequency column adds up to the total number of numbers. So here our cumulative frequency table is just simply a running total of how many data values there are up to and including that interval. Now what we're going to do is create a cumulative frequency histogram, which basically is the graph version of this last column of our table. So here, our cumulative frequency total is 30, so I'm going to make the height of the graph 30. And I think a convenient then interval value to use would be 10, so I'll go up by 10s on the y-axis. In terms of the bottom, I'm going to set up my intervals, and I have my 5 intervals beginning from 10, 20, 30, 40, 50, and the last line there will represent 60, even though it's not in my table. And now I'm going to create this histogram based on this last column. So here the first interval's cumulative frequency is 6, which means up to and including that first interval, we have 6 data values. Then for the second interval, it jumps to 17. Then through the third interval, it increases to 22. The fourth, we go up to 28. And then through the fifth interval, we reach the top of 30. And if you're doing these questions correctly, the cumulative frequency histogram always looks like a set of stairs, because by the time you get to this last interval, you want to have the total number of data values graphed. So in this case, we get all the way up to the top of 30.